All right, welcome, ladies and gentlemen. I am going to work through quiz number 2 on a nice little off the cuff kind of live stream here. So I'm not doing a Q&A or open kind of questions here, but basically I'm just going to kind of run through a quiz that I recently gave to my students over trigonometry. So in this quiz, we cover basically evaluating the 6 trigonometric functions. We learn how to evaluate the 6 functions. Evaluate the 6 trigonometric functions given an angle. Then we're going to talk about evaluating the 6 trigonometric functions given a point, given a equation and a constraint. And then we're going to talk about how to identify the reference angle as well as coterminal angles. And then we will finish with identifying the some multiple choice problems. So dealing with, again, evaluating for an angle, given some triangles, and then converting and so on and so forth. So we're about to go and get through that. One of the other reasons that I like to do these streams and not announce is I just want to make sure everything's kind of coming through because, again, as I mentioned, YouTube is changing some of the ways that they do the live stream. And I can just not get this new settings set up. So I'm not sure why it looks like that for me. So it's still showing that I'm live, so that's just so weird why that looks like that. But I'm going to go and try something else just so I can kind of see something. So before I get started, I just want to go ahead and try this and see what else I can maybe fix. So I do apologize for the little break. I'm not going to be doing questions again for those of you that are joining on. But I did want to see, a lot of times I can see my stream length on the original one. I can make sure that everything's coming through. But on this new panel, it is not connecting with my software. So I'm just not really sure why that is the case. Okay. Well, okay, well, it shows that it's going on. So, all right, guys, I'm just going to go and run with this. I'm not sure what's going on here. So I see some of you guys are on now. The old one's working. It says my stream is good. It's just so weird. The new software, the new live stream thing that they have is just not working out. So either way, you guys have joined on the stream. Again, I kind of disabled the chat for everyone just because I'm just not going to be able to, I just want to be able to focus and get on this. But I do appreciate you guys getting in there. And obviously I did kind of leave this in for the members, but I'm not really sure, how I really want to kind of continue doing the chat. But I just wanted to kind of do a quick little live stream, let you guys go through this quiz, and then I'll get on my way because I have 150 papers to grade. So I just wanted to knock this out for use, and then also so I can get my key online. But I will do another open Q&A, guys. Plan on doing that again this Sunday. So if you do have some questions you'd like to, send over my way, then please make sure that you just stay ready for on Sunday. And then you can, send them over via on my Facebook group or on the community tab in YouTube. All right, so let's go ahead and get started here. So in the first example, we're just evaluating, and we're basically, I told my students when we're doing these problems, I want to see the angle, I want to see the reference angle, and I want to see the point that you're using. Now, remember that we're evaluating these angles. We can go ahead and use the unit circle. So I kind of help my students out with identifying the unit circle, basically what I need them to know for the beginning of class, or before kind of at the beginning of the class, so they could kind of remember the unit circle, because we really just taught the unit circle. So I know it's something that we have not really done enough practice on. So, I basically said, all right, if we know we have the unit circle, it has a radius of 1, then those are the 2 easy points, right? And then we can basically break these up. And these first point, second point, and then third point. And really, if you can just remember the square root of 1, and then you can just follow the square root of 2, square root of 3, and then go back to the square root of 1, square root of 2, and then the square root of 3, and everything has a denominator of 2. And again, you guys have probably seen stuff on videos online. You have 5 fingers and there's 5 points, right? So it's very basic to be able to understand that. And then just to make sure that you understand the angles that we're dealing with, that's 45 degrees. I don't have room to write in the radians. That's 60, and that's going to be 90. But again, that's going to be equivalent to pi over 6, pi over 4, pi over 3, and pi halves. All right, so let's go ahead and I'm going to show all my work. So I'm going to sketch the angle in standard form. All the way around is 360. To get to 390, I need to go an extra 30 degrees. Now again, the reference angle here, I could say, is going to be 30 degrees. And you can see that the angle for 30 degrees is square root of 3 over 2, comma 1/2. Again, we're looking for the x-coordinate. For cosine is the x-coordinate for these basic functions. So therefore, that was going to be square root of 3 over 2. And again, you could just see in the first quadrant from there. For the next example, we have negative 150 degrees. So again, that's going to be in the opposite direction. And you can see, though, that that is going to be, again, with another reference angle, 30 degrees short of halfway around the circle. So we could say theta prime equals 30 degrees. So again, I'm going to go ahead and use 30 degrees here. Now again, we know that this is in the third quadrant. And the important thing about the third quadrant is both of my coordinates are going to be negative. So instead of it being positive square root of 3 over 2, comma 1/2, it's going to be negative square root of 3 over 2, comma negative 1. So that's the coordinate point I'm going to be using. The cosecant represents the 1 over y, or the reciprocal of negative 1/2, which is just going to be a negative 2. Tangent for negative 180, again, that's another negative angle. If you go to negative 180, oops. That's just going to take us here at the negative point, negative 1, 0. There is no reference angle because it lies on the x-axis. And the tangent here is going to be y over x, which is just equal to 0. Now we have our radians. So let's just kind of do these angles in radians just so you guys can see them. So that first angle is pi over 6. So pi over 6 is equivalent to 30 degrees. Then we have pi over 4, pi over 3, and then pi over 2. All right, so negative 11 pi over 6. Now, the main thing when we're graphing these that I told students is, remember when you're going in this negative direction, when you are going halfway around a circle, remember that's equal to pi. So if we're going to break pi into 6 different parts, well then 6 over 6 is going to represent pi, right? So all the way around a circle would be 12 pi over 6. Now again, we're going in this opposite direction here. So that's going to be 12 pi over 6. And we only went to 11 pi over 6. So that's going to be pi over 6 short. So we can say theta prime is pi over 6. Now, for pi over 6, again, I need to be able to identify the cotangent here for pi over 6. And so I need to figure out this coordinate point, which again, we have our same coordinate point here, which is 1/2. Oops, I'm sorry. And again, it's going to be in the first quadrant, so it's going to be square root of 3 over 2, comma 1/2. Now, the cotangent is going to be the x-coordinate over the y-coordinate. So therefore, when you take the square root of 3 over 2 divided by 1/2, that's just going to give you the square root of 3. Now, I messed that up. I did a different one for there. I'm just looking at my answers that I wrote down. That one's different. I have the square root of 3 over 2, comma 1/2, the x over y. I think I did my key wrong because that should have been cotangent is going to be x over y. Yeah, so that should have been square root of 3. So I made a mistake on that key. Luckily, I didn't grade any papers yet. So the next one is sine of 3 pi over 4. So let's go ahead and graph that. So sine of 3 pi over 4 is going to be over here. That's going to have a reference angle of pi over 4. So theta equals pi over 4. And therefore, now again, this is in the second quadrant, right? So, but an important thing in the second quadrant, x is negative, but the y is positive. And again, we're just looking for the y-coordinate. The reference angle pi over 4, so you can go to pi over 4. That's going to be that middle point, which is square root of 2 over 2. Since it's in the second quadrant, it's going to be square root of 2 over 2, because again, y is positive. And then last but not least here, we have 3 pi over 2, which is going to be all the way down here. That's going to have the coordinate point 0, comma negative 1. 0, comma negative 1, and the secant is going to be 1 over 0, 1 over x, which in this case is going to be undefined because you cannot divide by 0. All right, so that goes in evaluating basically using the unit circle. So I did expect my students to have the basic understanding of the unit circle. I did ask for them to represent the graph and the coordinate point. So therefore I could see their work and, they could show me what they understood, up to this point, even if they weren't able to get the right answer. All right, so for the next two questions, I did ask the students to provide also a triangle. And I think this is very important. If you're given a coordinate point, I think the first thing you should do is obviously graph the point. Like so, graph the 1, 2, 1, 2, 3. So you go ahead and plot the point. Now again, we're going to want to make sure we plot this point here in our standard form that we discussed. So that's going to be 2 units away from the origin and -3 units away from the x-axis, right? Now again, we want to be able to figure out what is that distance here. I'm sorry, it's 2 units horizontally away from the origin and -3 and 3 units vertically away from the origin. But we want to be able to figure out that direct distance, which is obviously going to be the hypotenuse, which we can use as r. So r equals 2 squared plus -3 squared. Let's see, 2 squared is 4, 3 squared is 9, so that's going to be 13. So r equals the square root of 13. And again, r is always positive, so we're going to have that there, right? Now, there's a couple important points here that I want students to make sure that we understood. First of all, actually, I lost my train of thought. What was I going to say? We have this coordinate point, and notice how that now the triangle is not just in space, but you can see that it is, that was it. You can see that it is down in the third quadrant. So you can see that is why the y coordinate is negative, right? I'm sorry, not third quadrant, fourth quadrant. It's in the fourth quadrant. So you can see why the y or this opposite side here is negative. Now, why here did I take the, x coordinate or the y coordinate or the x over y, and why can't we just do that here? Well, the difference is these triangles, I didn't draw any triangles, but these coordinate points come from triangles that are on the unit circle, meaning they have a radius of 1. They are 1 unit away from the origin. Whereas you can see this triangle is square root of 13 away from the origin. So therefore, you have to use our trigonometric ratios that dealt with r, like x over r, r over y, and so on and so forth. So again, this simplicity of as far as our trigonometric functions, as far as cosines x, sine is y, that only works when you have points on the unit circle. So in this case, we had to create our point to identify our triangle. We noticed it's not on the unit circle. So therefore, we need to incorporate the hypotenuse. So now that I figured that out, I'll just use, let's use sine of alpha. So I have sine of alpha is going to be the opposite over hypotenuse. So that's going to be a -3 over square root of 13. Then I'm going to rationalize the denominator to get square root of 13 or negative square root of 3, square root of 13 over 13. Then let's do the cosine of alpha. That's going to be adjacent over hypotenuse. So 2 over square root of 13. And that will give me positive 2 over square root of 13 over 13. And then I'm going to have tangent of alpha. And that's going to be opposite over adjacent. So it's going to be a -3/2. And again, the negative could go in front or you can leave it in the numerator. For the reciprocal functions, I am just going to reciprocate this. So I'm just going to put the negative in front. So it'd be a -13 over 3. For the secant of alpha, I'm going to choose square root of 13 over 2. Just the reciprocal there. Again, you don't want to use this reciprocal of the final answer there, because then you're going to have to rationalize the denominator again. And here I have cotangent of alpha, which is again just the reciprocal here, which is a -2/3. The other thing I wanted to point is a lot of people are like, why are you using alpha? Well, again, you're creating the triangle, right? So you can use any angle you wanted to, beta, theta, gamma, like whatever you feel like using. But the main important thing is this is the only triangle that works, that satisfies that coordinate point. Like +2, -3, has to be in that fourth quadrant. But as far as using the angle, you can use whatever angle, because again, just make sure your angle represents that central angle in the standard form that we talked about, right? Because I kind of gave students these 4 triangles. It needs to look like one of those triangles. Okay, and that was something that we just kind of discussed in our class as far as making sure that your angle that you're always referring to is right there, which we call the central angle. All right, so now let's get on to the equation and the constraint, which almost every single class asked about. So they definitely had some issues with identifying this, because when you're given a point, you don't really have to think about which quadrant the triangle's in. It kind of tells you, like, as long as you know how to plot the point, then, you basically just draw a triangle from there. But here, we have some restrictions here. We have cosecant of theta is equal to -3. Now, again, we need to understand what cosecant of theta means. Cosecant of theta, or of anything, remember, is hypotenuse over the opposite. It's a comparison, right? It's a ratio of how big is the hypotenuse, or how long is the hypotenuse compared to the opposite side of the triangle, based on your angle theta. Well, in this case, we don't have a comparison. We just have a number, -3. So again, we need to put it over 1. Now, we recognize that in this, if you write it like this, that the hypotenuse is negative, and we realize that the hypotenuse can never be negative, right? So therefore, this actually ratio can be better written as cosecant of theta equals the square root of 3 over -1. Now, opposite being -1 doesn't really help us out that much. But if you remember, when we looked at triangles in the coordinate grid, like, yes, we could say opposite over hypotenuse, but like what we did last example, if this is xy, like that's the y, that's x, and that's r, right? So another way to represent the relationship of cosecant could be, instead of hypotenuse over opposite, we could also say it's r over the y coordinate. And again, obviously, when these points are in different quadrants, you're going to have different positive and negatives. So since we know that this relationship is negative, and that y and that r is always positive, which represents your hypotenuse, then we know that y has to be negative. So that means we only have 2 options that make sense here, right? We only have 2 options here. So let's go ahead and draw those 2 options. I could have a triangle down here, or I can have a triangle down here. Because I know the hypotenuse is square root of 3, and I know the opposite side is -1. So those are my only 2 options. Those are my only 2 triangles. Because if I do triangles up here, obviously my y coordinate is going to be positive. And if cosecant of theta is equal to negative square root of 3, or anything negative, then the y coordinate has to be negative. So now our next relationship that we have is the tangent of theta is greater than 0. Well, again, if tangent is opposite over adjacent, that doesn't tell you if something's positive or negative at all. But if you look at tangent as y over x, you can say that, well, when tangent is greater than 0, that means tangent is positive, right? That's just a fancy way of saying something is positive. Well, y over x is only going to be positive when both y and x are positive, which is the first quadrant, which can't be true, or when y and x are both negative, which you can see is going to be true here in the 4th quadrant. So the triangle we are going to use here is going to be -1, square root of 3, and then we got to be able to use Pythagorean theorem here. Now again, the important thing is, since we're going to the left, we know that this side length is going to be negative. So let's go and do the Pythagorean theorem here real quick. So square root of 3 squared equals -1 squared plus, I don't know, a squared. And therefore we get 3 equals 1 plus a squared. So we can say a squared is equal to 2. And therefore a equals plus or minus the square root of 2. But again, since we're going to the left, we know that a has to equal a negative square root of 2. So that is going to be a negative square root of 2. Now, we have to be careful writing our angle in space here, because again, we see that our angle here, because we're dealing with theta, is the central angle. So this is going to be our central angle here, or the angle that we're going to use for the triangle. And again, that is going to tell us where is our opposite side and where's our adjacent side. The hypotenuse is always the hypotenuse, but making sure that you are aware of where the angle is, you can identify the opposite and the adjacent. And now we just need to evaluate our 6 trig functions. So the sine of theta is going to be opposite over hypotenuse, so that's going to be a -1 over the square root of 3. Rationalize the denominator, you're going to get a negative square root of 3 over 3. I forgot to mention one more thing too when I grade these, which I'll come back to. The cosine of theta, in this case, is going to be adjacent over hypotenuse, so that's going to be negative square root of 2 over the square root of 3. Again, rationalize the denominator. You get negative square root of 6. Square root of 3 times square root of 3 is just 3. Do not try to divide the 3 into the 6. The 6 is under the radical. 3 is not, so you can't do that. The tangent of theta is going to be opposite over adjacent. So that's going to be -1 over the square root of 2. Rationalize the denominator. That's going to be negative square root of 2 over 2. Kind of run out a little space here, but I'll try to do my best. Cosecant of theta, which is just the reciprocal of sine, is just going to equal a negative square root of 3. The secant needs a little work, so I'm going to put that down here. Secant of theta is the reciprocal of cosine, so that's going to be a negative square root of 3 over square root of 2. And again, rationalize the denominator here, and you would get a negative square root of 6 over 2. I'm not showing my work in this case, but again, don't divide the 2 into the 6. And then for cotangent, we're just going to do the reciprocal of tangent, so that's going to equal a negative square root of 2. Now, one thing I want to make you aware of on question number 2, as well as on question number 3, is the quadrant that the triangle lands in matters. That tells you the positive and the negatives of each trigonometric function. So when it's in the fourth quadrant, I know that since the y-coordinate's negative, my sine and cosecant should have been negative, and my tangent and cotangent is negative. So when I'm grading these as a teacher, that's what I'm looking for. And I also know that the cosine and secant are going to be positive. In the same respect, in this example, we have our triangles in the fourth quadrant. And I'm actually just going to draw this little XY axis just to kind of remind myself it's not in space, it's in the fourth quadrant. So therefore, sine and cosecant should be negative, cosine and secant should be negative, yet tangent and cotangent should be positive, and that's where I made my mistake. So I did not use a negative over a negative, so that should have been a positive. And you can see how that's a great check, right? So I forgot to put a negative square root of 2 or something like that. So therefore that's a positive, so therefore that cotangent also needs to be a positive. All right, for question number 4, it says, given the following angles, determine the reference angle and the smallest positive and negative coterminal angles. Remember, the basic definition of coterminal angles are angles that start at the same that have the same initial and terminal side. The easy way to identify coterminal angles is really just to add and subtract 360 or add and subtract 2 pi. So in this first example, I am just going to, since all I'm asking in this case is find the smallest positive and negative coterminal angles. So whenever you have an angle that's within 0 to 360 within a revolution, you can just add 360, and that's going to give you the smallest positive. So let's see. So my coterminal angles. So 120 plus 360 is going to be 480. That's going to be my smallest positive. And then the smallest negative, I am just going to subtract 360, which is going to give me a negative 240 degrees. So those are going to be my smallest, that's the smallest positive, and that's the smallest negative. To find my reference angle, sometimes it might be helpful to graph this. But again, we should kind of know like halfway around a circle is 180, right? Halfway around a circle is 180. And you just traveled 120. Well, how much farther do you need to go ahead and get to the x-axis, which is, the definition of the reference angle? Well, you need to travel 60 more degrees. So theta prime is going to be 60 degrees in this case. And again, notice how the problem was presented in degrees, and I kept everything in degrees. Now, in this next example, this one brings up an interesting case here, because if I keep on subtracting 2 pi, I'm just going to keep on getting a bigger and bigger negative angle. So rather than adding and subtracting like a revolution like I did over here, I'm going to add, because again, I want one positive angle, one negative angle. Well, if I keep on subtracting, I'm not going to get, or even if I add 2 pi, which in this case, 2 pi is equal to 6 pi over 3. So if I add 6 pi over 3, I'm going to get here a negative 2 pi over 3. Which is great. Negative 2 pi over 3 is the smallest coterminal angle, because negative 2 pi over 3, if you add 6 pi over 3, you're not going to get another negative angle. So that becomes negative 2 pi over 3. But if I want to find the next positive one, I need to add 6 pi over 3 again. And by adding 6 pi over 3 again, I now get 4 pi over 3, and that is the smallest positive angle. So in this scenario, we actually needed to add 2 pi twice. And again, when you're dealing with radians, a lot of times it's just easier to represent them instead of doing 2 pi as 6 pi over 3. As far as finding the reference angle, it's helpful just to kind of understand this graph. So going in the negative direction, this is going to be negative 6 pi over 3. Oh, come on. All right. So that is going to be a negative 6 pi over 3. And therefore, we'd have negative 7 pi, negative 8 pi. But again, you can see that the reference angle is just going to be pi over 3. And again, remember that reference angles are not negative. They are always positive and they are always acute. But you can see that reference angle is how far is that angle away from the x-axis, which in this case is pi over 3. So that does it for our free response portion. Now let's go ahead and get into the multiple choice section. So on the multiple choice section, what we're going to have here is find the cosine of 7 pi over 6 exactly. So again, this is just basically knowing your unit circle here. So we're going to go ahead and sketch the graph at 7 pi over 6. All right, recognize that coordinate points. So the reference angle here is pi over 6. So the coordinate point of pi over 6, but that's in the third quadrant. It means it's going to be both negative. So it's going to be a negative square root of 3 over 2, comma negative 1/2. So the cosine is the x coordinate, which is b. As far as finding the cosine here, we need to figure out the hypotenuse, so we can use Pythagorean theorem. So this is 36 plus 25, which is going to be 61, or square root of 61. So the cosine, again, is the adjacent side. Remember, adjacent is always between your angle and the 90 degree. So that's going to be, so the cosine of theta is going to be 5 over the square root of 61. And you can see they rationalize the denominator here, which is answer B. The next one says, suppose the radian measure for the angle of theta is negative 6 pi over 5. What is the degree measure for this angle? So therefore, we need to convert this to degrees. So we have negative 6 pi over 5. And we're going to times that by, we're going to multiply that by 180 degrees over pi. So that is what we call our conversion ratio. Now, there's a couple different ways you can do this, right? And some students, I'd say, my students didn't have a calculator. So I said, go back to your roots. Like, how many times does 5 go into 180 degrees? Well, 5 goes into 18 3 times. 3 times 5 is 15. Subtract. 5 goes into 30 6 times. 6 times 5 is 30. There's a remainder of 0. So therefore, we basically have that 5 divided into 36 here. The pi's divide out. That goes in there 36. We're basically left with negative 6 times 36 degrees. And then we basically just need to be able to figure out which angle is going to be. And again, remember, this is a negative. So obviously, it's going to be a negative angle. And 6 times negative 36 is going to end in a 6. So you can see. But again, like, let's say, I don't know. Let's work it out again. Like, forget about the negative. 6 times 6 is 36. 6 times 3 is 18. Plus 3 is 21. And again, remember, that's a negative, right? So you can see that's a negative 216. That's why B is the answer. Question number 8 says the cosine of theta is 8 over 17. And the angle is between 3 pi over 2 and 2 pi. So where is 3 pi over 2 and 2 pi? Well, that's going to be in the fourth quadrant. So let's draw this triangle. Everything's cosine in this case. So we have 8 and 17. Here's going to be my theta. And we're trying to find the cotangent. So I know it's not going to be, so again, the cotangent is going to, or sorry, yeah, you're finding the cotangent, which again, remember, cotangent is going to be x over y, right? Now, I think you guys can agree that, now this is going to be negative, so this is positive, it's not going to work. Now, I'm pretty sure it's not going to be 3, because 8 squared plus 3 squared 9 is not going to give me 17 squared. I don't even know what 17 squared is. But out of my answer choices, these 15s, I'm going to go with that, right? And again, since I know 8 is my x and this is my y, I'm just going to go with D. So I'm not even going to do any math. I'm just going to go with 15. And I'm assuming then this is a Pythagorean triple, right, that I wrote on the board that I, supposed to like kind of recognize. But again, I can just kind of deduce based on my answer choices the correct answer. All right, last question, number 9. So I have a coordinate point, and they're asking me for the sign. Now, if this point is on the unit circle, the answer is the y-coordinate, which is A. But again, that is only if and only if this point is on the unit circle. So how can we judge, or how can we determine if this point is on the unit circle? Well, we could use the Pythagorean theorem. Now, again, you can kind of, and again, by using the Pythagorean theorem, what I mean by that is if you use the Pythagorean theorem, and you get a hypotenuse of 1, or you get r squared is equal to 1, then you know r is 1, which is the hypotenuse, right? So 2/5 squared is going to be 4/25, plus the square root of 21 fifths is going to be 21/25 equals r squared. Well, this becomes 25/25 equals r squared, which is 1 equals r squared. So we know r is equal to 1, right? So since this r is equal to 1, that means this point is on the unit circle. So therefore, my sign of this function is going to be y. So there you go, ladies and gentlemen. I hope you enjoyed my first little quiz. We will have another quiz after Thanksgiving, at least in the United States for us. We'll have quiz number 2. And then we will get prepared for our semester exam. So until I get this feature figured out for you guys, I'm going to have to unfortunately keep these chats kind of off just because it's like too many things going on. But I want to get this figured out for you guys. And then we can, on these impromptu, you guys can go ahead and join on the chat. So I'll get that fixed up. But hopefully this helped you guys out. And if you do have any other questions, feel free to add them into the chat. All right. Have a great night, guys. Cheers. No, that was the wrong one. Oops. There it is.